Okay, now we're going to put the notes on the inside. If you've printed this out already, the notes should already be inside with spaces to write notes. Now I had to, when I printed it, I had to finagle it around and cut it properly so that everything would fit perfectly. Just so you know, for teachers, if you're using this video, when you print the copies, you can't do it back to back. You have to do 2 pieces of paper and then you'll have to glue them together. Okay, anyways, so using my example, first thing I want to make sure I do is go through and cut my flaps. Cut along the edge right to the crease on both sides. Okay. Then we have to go through and make sure we color and highlight as we go. I'd like to give it some color because in black and white it's just boring. Make things pop. Okay, so let's put some color in there. We're going to talk about the product rule first. Remember, the product rule is when you are multiplying exponents that have the same base, you can just add the exponents. So I'm going to highlight that those exponents are different and where they're located on each of them. I'm using red. You can use whatever color you want. Something I wanted to note here too, when I made the other video, I stated here that you'll sometimes see the numbers next to each other like this, and that was not true. Oops, I want to use green. That is not true. It only looks like this if you're working with variables. You can't put numbers next to each other like that, 2 exponents next to each other like that. You can, but you don't usually see it like that. You only see it like that when you're dealing with letters. Okay, so product rule. As long as the bases are the same, you can add the exponents. I took those notes right here for you. When you multiply powers with the same base, keep the base and add the exponents. I'd like to highlight those key words. We are multiplying, so I'm going to put a little box around the word multiply. And when you multiply, you add the exponent. So I'm going to highlight those 2 words and color them in. Whatever color you want to, it doesn't matter. Just so you note to yourself, when you're multiplying exponents with the same base, you add the exponents. Just to give it some color. Okay, so let's go over the examples now. Say for instance I have 3 to the 5th times 3 to the 4th, and notice I used a time sign here. You don't have to, sometimes you'll see it with the dot. 3 to the 5th times 3 to the 4th, if I use the rule, I would just keep the base. The base is 3. And add the exponents. So 5 plus 4. Well, 5 plus 4 equals 9. So that becomes 3 to the 9th power. Now why does this work? Well, if we expand them out, you can see it easier. 3 to the 5th means 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5 times. Because it says to do it 5. 3 to the 4th is 3 times 3 times 3 times 3. So add 4 more. 3 to the 4th, 4 more bases of 3. When you add those all up, you get 1, 2, 3, 4, 5, 6, 7, 8, 9 times. It becomes 3 to the 9th power. Okay. That's why that example works that way. Example number 2. This works the same way if you're dealing with a negative exponent, and I'll explain why afterwards. We are multiplying, the bases are the same, so I just need to add the exponents. It says to keep the base, so I'm going to keep the base, and then I'm going to add the exponents. -1 plus 3. I like to put it in parentheses, especially when you use negative exponents. Alright, but now we need to do that math. What is -1 plus 3? Alright, well I got to write the base again, and then think to myself, -1 plus 3 is the same thing as 3 minus 1. 3 minus 1 is 2, so -1 plus 3 is 2. Or think to yourself, you're starting in the negative at -1, and then you move into the right 3 places, you'd end up as a +2. Why does this work? Well, If you remember earlier in the front, I explained that when you have a negative exponent, you have to rewrite it with the reciprocal and take away the negative. So that's what we would do. 4 to the negative 1 becomes 1 over negative 4, or 1 over 4 to the first power. I keep the exponent and get rid of the negative by putting it under 1. And then we still have 4 to the third power. Well, that's a positive, so that's on top. And the base becomes 1, or the denominator becomes 1. I go to expand that, I end up with 1 times, get rid of the 1, 4 to the I end up with 4 to the third power over 4 to the 1. 1 times 4 to the third power is 4 to the third power. 4 to the first power times 1 is 4 to the first power. If I expand those out, I get 4 times 4 times 4 on top, and 4 on the bottom. Knowing that anytime you divide a number by itself, you get 1, I can cancel out any ones that are the same. I'm left with 4 times 2 in my numerator, which becomes 4 squared. Okay? Last example. This rule applies even if you're multiplying more than 2 exponents. As long as the bases are the same, you can just add the exponents. So we have 2 to the third times 2 squared times 2 to the fourth power. That becomes, keep the base, add the exponents. 3 plus 2 plus 4. Okay, now I have to do that addition. Keep my base again, and actually add them. 3 plus 2 is 5, 5 plus 4 is 9, so this becomes 2 to the 9th power. Below that, we can show why. If we expand out, you will see that this equals 9. Multiplying 2 by itself 9 times. 2 to the third becomes 2 times, oops, my pen died there. 2 times 2 times 2. Multiply the second, the 2 squared, it's 2 times 2. Oops, my pen is not working well. Okay, and then 2 to the fourth power. 2 times 2 times 2 times 2. I'll do it 4 more times. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see that works out that I've multiplied that base of 2 by itself 9 times. Okay, and we're done with our examples for the product rule. We'll move on to the quotient rule. And again, I'd like to color in the title, give it some color. I use the same color you used on the other one, but it doesn't matter if you do. I like to keep it the same though. So color in the top. Remember, quotient rule is when you are dividing, because quotient means division. You're dividing an exponent by an exponent. They can be the same exponent, but the base has to be the same. Alright, let's see how that works out. Our notes on the inside. It says that when you divide powers with the same base, keep the base and subtract the exponents. Again, let's highlight those key words. We are dividing, and when you divide powers with the same base, you subtract the exponents. And color that in. When you divide, you keep the base and add the exponents. Okay, let's do some examples. Alright, we have 2 to the fourth divided by 2/3. This says that all I need to do is keep the base and add the exponents. The base is 2. The exponents are 4 and 3. So I need to add 4 plus 3. 4 plus 3. 4 plus 3 is 7. So keep my base, and my answer is 2 to the 7th power. 2 to the 4th. Oh, I added. I'm silly. I mean to subtract. Subtract that. 4 minus 3 is 1. See? It's been a long day. My son has interrupted me several times today, too. Okay, so that's supposed to be subtract. I need to fix that. That still looks like a plus. I didn't use my rules the way I was supposed to. I was stuck on multiplying. Forgot that I was dividing. Okay, let's do that again. Should be 4 minus 3. And 4 minus 3 is 1. So our answer would be 2 to the first power. Why does that work? Let's show it out the same way that we done the other ones. 2 to the 4th power is in our numerator, so let's show that in expanded form. 2 to the 4th power is 2 times 2 times 2 times 2. 2 to the 3rd power is 2 times 2 times 2. And again, using that same rule of any number divided by itself equals 1, so we can just cancel it out. And we are left with just 2, which is the same thing as 2 to the 1st power, because using our rule over here of any number to the 1st power always equals just that base, because you really haven't multiplied anything. Okay, another example. Now I have a negative in the exponent. Does it work the same way? Yes, it does. It's a little more complicated to explain why, but if you follow the basic rule, it works the same way. If you're dividing, you keep the base. Our base is 4, and add the exponents. We have negative 5 plus 3. Negative 5 plus 3. Subtract the exponents. I did it again. Oh my goodness. Yep, it's getting late. And I'm tired. Negative 5 minus 3. Okay? Add those exponents. Alright, keep our base again, and let's do that math. Negative 5 minus 3. I'm starting at negative 5, and I'm going further into the negative 3 more times, so it becomes negative 8. To explain why that works is a little bit more complicated. The reason why is we have 4 to the negative 5 divided by 4 to the 3rd. I can rewrite 4 to the negative 5th as 1 over 4 to the 5th using our negative in the exponent rule. Put 1 in the numerator and put your exponent in the denominator, removing the negative. So I have 1 over 4 to the 5th divided by 4 to the 3rd power. The reason why I put it up on the top there is because I need to remind myself that any number can be made into a fraction by putting it over 1. So I put it that way because I want to make sure that I'm keeping everything even. If you remember, when you divide fractions, you are actually multiplying by the reciprocal. So I'm going to go ahead and do that. I keep 1 over 4 to the 5th power, and I have to multiply by the reciprocal. So I'm flipping these two. 1 over 4 to the 3rd. Okay? Now we can go back here. Now we're multiplying using the product rule. Using the product rule, you should add the exponents. It's okay that it's in the denominator. It works the same way. So we end up with 1 over 4 to the 5th times 4 to the 3rd, which is the same thing as 4 to the 5 plus 3. Okay? And again, I gotta keep going down here. That changes to 1 over 4 to the 8th. Have we met 4 to the negative 8 as our answer yet? We have. It's just not in the right form. We're in the opposite form of dealing with a negative exponent. Remember, if we have this, I can just turn it back to that. So I can rewrite that as 4 as my base to the negative 8. Because 1 over 4 to the 8th is the same thing as 4 to the negative 8. Told you that explanation would be a little bit more complicated, but the rule works the same way, whether you have negatives in the exponents or not. If you remember this rule, it'd be easier to get the answer here than doing all this work. And doing all this work down here. I think I was off the screen. Okay, so moving on. We need to do the power rule now. Power rule. Power rule. Okay, remember, power rule is when we're dealing with multiplying a power to a power. Power to a power, power to a power.